Hello YouTube, welcome back to my channel. So in today's video we're going to continue with our series on computer vision using opencv in Python. So in this video we're going to go and look at how to detect shapes in shapes or objects within an image and be able to count them. In this case we're simply going to detect each of the shapes within this image and you simply draw a mark around them, and simply we're going to return a count of how many shapes are within this image. That's what we're going to do. So let's get started with it. And you guys, if you're new to the channel, please kindly consider subscribing, liking this video, and sharing this content with anyone who you think might find this helpful. So let's get to it. So I'm just going to go ahead and create a simple file here. I'm just going to call this going to be video 7, so basic underscore 07 .py, just like that. So once I have this video, I'm going to go ahead and import cv2, just like that. So once I have cv2 imported, I'm simply going to go ahead and simply read the image. So let's go ahead and actually read the image. So I'm going to say image, and this is going to be cv2.im read, and then providing the path to that image, and the path is going to be /images/shapes. So let me get that right, shapes 1.png. okay. So once I have that right, I'm just going to go ahead and display that image. Okay, so I'm going to go ahead and display the image. I'm going to cv2.im show. I hope by now most of us are familiar with doing this. I'm going to say image, and then I'm going to go ahead and simply pass in here my image, and I'm going to wait for this. I'm going to say cv2.wait key, and you're going to simply wait for infinite until the person press a key on the keyboard. Yeah, that's basically it. So once we have this here, we're going to wait until the person press the key on the keyboard, and then I'm going to quit. Okay, so yeah, let's actually go ahead and see if this will work. So let me just clear the terminal and then just go ahead and simply run Python, and just use sudo. So sudo python 3, and this is going to be basic underscore 7.py, and then simply run that. So we have an error here. I see okay.
Yeah, so we're getting this error because I just realized something. I forgot to actually specify the right path to this. So this is actually images and not image. So it's going to be images/shapes1.png. Okay, so sorry for that. So once I have that, I can simply run it, and now you can see we are reading the image and displaying it here. So I'm just going to press any key on my keyboard to quit that. So make sure you specify the right path to image. For some reason, I'm always making this error within this series. So sorry for that. So once I have that done, I'll simply read the image, and now I have displayed the image. So the first thing I'm going to do is convert the image into a grayscale. So I'm going to say gray, and I'm going to say cv2.cvt color. You have learned already how to do this. I'm going to pass in the image, and I'm going to convert this image to a grayscale. So I'm going to say cv2.color underscore bgr, and then to gray, just like this. So once you have this, is going to be a gray image. Now you can go ahead and display the gray image here. So just like this, gray. Okay. So once I have that, I can simply run it, and now we should have the image in gray color. Okay, so great. So once we have the image done, converted into gray color, we're now going to go and detect all the edges within the image. And to detect all the edges within the image, you're going to be using the canny. Okay, so I'm going to go ahead and create an image. I'm going to simply call it, let me just call it edges, edges, and you're going to simply do cv2.canny, just like this, canny. And you're going to pass in the image that you want to detect the edges in. So this is going to be the gray image, and then you're going to simply pass in like the minimum and the maximum. We're going to say 30 by 1, let's say 170 or 160. Okay, let's go with 160 and let's see how it is. So once I have this, I'm about to display the canny image and not the gray image. Okay, so I'm going to say edges right there, and I'm going to simply run it. And let's see what we get. So you can see we have successfully detected all the edges within the image, or all the edges have been detected. Great. So once we have the edges being detected, now we want to go ahead and simply convert our image into the threshold. So the threshold is basically helps to reduce getting the threshold helps to reduce the darker or the lighter parts within an image, just basically what thresholding does. So let's actually go ahead and try to do that here. So I'm going to simply get the rate. And then also what you're interested in is the image threshold that we get. So we're going to say cv2 dot this is going to be threshold. So threshold, I hope it's put like that. So threshold, and you're going to pass in a gray image, grayscale image. We're going to say 225, let's just say 255, and I'm going to say cv2 dot this is going to be uppercase. So threshold, and you're going to say underscore binary, so binary underscore invert. Okay, invert like this. So threshold binary invert. Okay, so inv. So yeah, this is actually thresh and not threshold. So this thresh underscore binary underscore inv. Okay, So once I have this done, this is going to return to us the threshold image that we get. So actually, let's try to display it and let's see what we get. So I'm just going to say this is going to be lowercase, so threshold, which is what we get here, right? So this variable right here. So actually run it and let's see what we get back. Hopefully I haven't made any typos. So yeah, this is what we get back. Instead, simply return to us the each of those shapes that we have inside of the image colored in white. Okay, so great. So now once we have the thresholds specified, okay, now we're going to go ahead and can apply a bit of erosion to it and do all of that. But before we do that, actually look at the contours and let's display the image inside of those contours. So I want to do that. Say contours, and this contours I'm going to say, and then hierarchy. So hierarchy, and then I'm going to say equals to, and I'm going to say cv2 dot find contours. I always spelling of contours, so then we contours just like this. So find contours, and you're going to pass in the threshold image that we have, and you're going to simply go ahead and simply pass in the cv2, and cv2 dot we say itr, okay, and then an underscore external, okay, and then you're going to say cv2, and this will be cv2 dot I'm going to say chain underscore approx underscore simple, just like this. So this is going to just help us to get all the shapes back within an image. This can help us to get back all the contours within an image. So I'm going to specify these arguments right here that we have passed in. Okay, so I'm not going to go and explain this to you. You can read more about this on the official documentation of opencv-python. Okay, so this just helps us to get the threshold, let's get the hierarchy, and then the threshold count. The contours, or my bad, not threshold, contours. So it will help us get the contours of all of this threshold, and it's going to run to us in order of hierarchy. Okay, so but what you're interested in is the contours, right? Because each of those contours shows the where each image is. Okay, so now that we have this value right here, let's go actually go ahead and we're going to use a for loop, and then we're going to go ahead and simply simply plot a line showing where the image, the shapes are. Okay, so let's say for this going to this lowercase for contour in contours, right? Okay, so we're going to go ahead and do cv2.draw contours, just like this. So draw contours, I'm going to pass in my image where I want to draw it on the image, and I want to specify the contour in form of list. Okay, and then I want to just simply say -1. I'm going to get all those contours, and then I'm going to say the color, which is going to be 225, 0, 225. You can use any color that you're comfortable using. I'm going to specify the thickness to be 3. So once we have this, I want to go ahead and actually display the image itself. Okay, there's the original image because we are drawing on the original image right here. So I'm just going to go ahead and run this again, and you can see we have the lines being drawn around those images right here. Okay, good. But one thing you can realize, let's try to actually count the number of images that we have. So let me just go ahead and just simply get, let me just print this and say objs, right? Objs or shapes. You can just say it's going to be the length of counts, right? And we can simply go ahead and simply print the objects counts up, like how many objects that we have or how many shapes that we have. So I'm just going to go ahead and simply run this again, and let's see what we get. So we get back 25. Wow. But then obviously not 25, because if I run this, we just see we have 1, 2, 3, and 3 by 2 is 6, right? So it's just 6 images and not 25 as we are specifying. So how can you do to improve the accuracy of this model? The first thing we can do actually, we can go ahead and try to do erosion. So erosion just helps us to reduce the noise inside of the image. So there's erosion, is also dilation, but dilation is just have to increase the size of some foreground images, and while erosion helps us to get rid of what we don't basically need. So what I'm simply going to go here, I'm simply going to go ahead and simply say erode. So erode underscore going to erode image, then we need eroded image, or it's called erode image, and I'm going to do the cv2 dot erode, just like this, and I'm going to pass in what image I want to erode. In this case, I'm going to pass in the threshold image, and then I'm simply going to go ahead and specify none. We're going to say none here, and I'm going to go ahead and say the number of iterations. So number of iterations is the number of times that will go in to reduce the number of noise in our image. So how many iterations? So the more iterations you have, the more the noise is reduced. Because if you look at the image right now, let me actually show you something that I wanted to show. So let me actually import numpy here. So I'm going to go ahead and import numpy. So I'm going to import numpy as np. So I'm going to go down here. I'm going to say let me say final underscore image is going to be np.horizontal stack, horizontal stack, and in here going to provide in a list. So I want to go ahead and I want to start the, let's see which images I want to start. So I want to go and start the Kani image, which we call ages, right? So we call it ages. So ages, and then I also want to go and start the threshold. So the threshold image, just like this. So I'm going to start these two images, and actually let's go here and display that final images, right? Final image right here. So let me run the code again and let's see what we get. So let me run the code and we have this right here. So if you look at this list part closely, you can see that the shapes are not properly being identified. We have different lines, right? So those different lines is what makes it counts up to 25, because you can see here, like we have this gap right here, and then we have a line, and then we have a gap, and then we have a line. So that's not perfectly done. So by using erosion, you can actually make this to be much more perfect. So actually, let's go ahead and try to apply the erosions to it. So this is going to help us to get the erosions, right? So once we have the erosions being detected, I can simply replace add this to it. So I'm just going to say add this right here. So this can be let me see, I called it erode underscore image, just like that. So erode image is going to return to us the image after I try to perfect it and try to reduce the noise inside of that image. So this will help us to get the actual contours and not a value that we're going to get. So in this case, actually, doesn't we don't get the lines properly, because in here I use the the threshold image. But if I use a gray image like we did up here, now we should be able to get a view of that. So I run this again. So we get the views right here. The views actually not better right here. So let me see what I used here. Ages. So for ages, I use the gray image. So the road, I also use the gray, and more of iterations. Let's specify more of iterations right there. So this should be ages, and this should be gray. So let me just check. If we run this. So we have this right here. So this is the second image. So let me see why I'm getting that. I want to get it in place in black and white. So this is eroded images, cv2.erode, and I pass in the gray, and number of iterations is this for now. Okay, so what we're simply going to do is instead of passing it, when I go into getting the contours, right, instead of passing the threshold image, I want to pass the eroded image where we reduce the number of the noise inside of the image. So we simply say erode image, just like that. So once I pass this, now we should get a clearer image view. Okay, so just run this. Okay, so once we have that, we can see we get back the results this way. So what I also want to go ahead and do is bring the object to be 1. Okay, so to do this, I'm going to go ahead and simply pass in my final image, because we are drawing on the final image. I want to see how many shapes we have on the final image. So run this. So on the final image, we have this, and it's detecting only one of these. It's detecting the main image and not the different images within the main image. So how do we do to address this condition? Okay, so let's go and look at it properly. So here we're getting the hierarchy and the threshold of the image. Okay, so here when you're trying to get the contours, we're passing in the erode image, and then you're passing in these values right here. And then for the object, you're getting the object count to be 1 instead of the different object counts that you're supposed to get, which is wrong, right? So let's actually check the number of iterations that we're doing here. So the number of iterations, we will say iteration equals to true, and the image that you're trying to erode here should not be the gray image, should be instead the threshold image that we have here. So now once we have this, now let's run this again and let's see what we get. So now we got back 6, the value right here, 6. So after doing the erosion, now you can see the noise in the image has been reduced. And when we reduce the noise in the image, and you try to find the contours within the image, you're going to get a better value, since it's going to be able to find the exact contours rather than all the included noise inside of the image. So by eroding the image, you're trying to reduce the noise, and by reducing the noise, you're going to get a better view of the contours and a better count of the contours. So you can see in this case that we get 6 different contours, and each of those contours is what forms the image that we have right here. Yeah, so that's basically it. So just by using this code, we're able to get the image count, to get all the images, and then get the count of all the images. So whenever you're trying to get a count of all the images and you're getting a weird value, just try to use erode and erode the image by passing the number of iterations here. So the number of iterations tells how many iterations, how many times you should erode, right? So the number of iterations should go. So erode the image. So basically, this is what you need to do in order to get the different shapes in an image. In this case, we have 6 individual images, and if you count here, it's telling us we have 6 objects being detected, or 6 different shapes being detected. Yeah, so that's basically it for this video, and we are going over how to simply count a different shapes within an image using contours. And that's also what I wanted us to talk about in this video. If you enjoyed this video so far, please kindly consider liking this video, subscribing to the YouTube channel, and sharing this content with anyone who you think might find it helpful. Okay, so thanks for watching, and see you in the next one. Keep safe.